Okay, so this starts your experience in homework for Math 151. And so basically what we do here is I work through the solutions for you, and then you're supposed to hopefully do it yourself and then come to these if you need help. But I know a lot of you are going to just basically watch the videos and write down the solutions. But I encourage you to do it, try it on your own, at least a little bit, and then come to these later. And what I'm mostly going to do is go about every fourth problem. So I'm going to start with problem number 1, and go to problem 5, 9, etc. And what I'll do is, what was I going to say? Oh, I do it so the videos are about 10 minutes long, so however many problems it takes that long to do. So I don't just do one video per problem. I usually do a number of videos. Okay, so we're going to start with problem number 1, section 1. And what we talked about here was inductive reasoning. Inductive reasoning basically says that you go from a specific examples to a general solution. And if there's any one specific example, so you look at some specific results, experiments, and you say, well, this is like based on those experiments that this is what I think is going to happen. And so you come up with a rule or law, something like that, and then, but all it takes is one specific example to basically make it so that your rule doesn't work. Okay, the other way, deductive reasoning, is you start from the general concept and then use that general concept to come to some specific conclusions. This is using a specific examples to come to a general conclusion, and then that you can apply to all situations. Okay, so problem number 1 says determine whether reasoning is an example of deductive or inductive reasoning. So is it inductive or deductive? So as it if the mechanic says that it will take 7 days to repair your car, then it will actually take 10 days. The mechanic says, I figure it'll take a week to fix it, ma'am. Then you expect it will be ready 10 days from now. So in this case, basically, we aren't looking at examples of mechanics. You know, it's not like you go there and observe the mechanic do it in 7 days, and then it takes 11 days, or then the next time he says it's going to take 7 days, it takes 9 days. And based on that, you say on average it looks like it takes him 10 days when he says 7 days. That would be inductive reasoning. In this case, it says if the mechanic says 7 days, then it will take 10 days. So that's the general concept. So if then he says, I figure it'll take a week to fix it, which is 7 days, then you use the general result. So in this case, it's deductive reasoning, because we're taking the general comment and applying to a specific example. Okay, let's look at number 5. Finley has 85 baseball cards. His mom gave him 20 more for his birthday. Therefore, he now has 105 of them. So how do we get to that? Well, we use the rule of addition. The general rule of addition, it's a number line you add. So you basically start with a number line which would start at 0, and you go to 85, which is the amount he starts with, and then you add 25 more, or 20 more. That means you count 20 units from 85, and you get to 105. And so that's the general rule of addition. And so we're taking the general rule of addition, applying to a specific case here, which is 85 being your first number, 20 being the number you add to the first number, and 105 being the result. So this one is also deductive reasoning. Okay, number 9. It is a fact that every student who attends Delgado University was accepted into graduate school. So this is probably one particular year. And so up to this point, every student, you do an experiment. You say, okay, here's a student from Delgado University. Oh, the result is he got into graduate school. But it's not like it says that just because he goes to that school that he automatically gets in. It's not one of the requirements of admission or one of the results of the college. You graduate, you get into graduate school. It was particular experiments. So when it says, because I'm attending Delgado, I can expect to be accepted into graduate school too. So that you're using inductive reasoning. We use the experiment that said everybody was accepted, but it doesn't mean that everybody gets accepted. But it's expected that they will be accepted based on past experience. So that's in the case of inductive reasoning. Okay. Let's just do one more in the case of inductive reasoning. So I'm going to do a number 11. And it says, in the sequence 5, 10, 15, 20, 25, the most probable next number is 30. So this is our data. Basically, we've got 5 data points, and we see this pattern. Hopefully we see a pattern that each number is 5 units greater than the previous number. So this is our experiment. We look at the difference between these two. We look for a pattern, and we see that going from each number to the next number, we add 5. And so the most probable result of this is going to be 30. So we would say 30 is the most probable next number. Now there could be sequences that the next number is not 30. There could be some pattern that we don't recognize by looking at it, but the one that we recognize most easily is adding 5 to each one. So again, we're taking the specific cases, and we're looking at 5 specific cases here, going from 5 to 10, actually 4 specific cases, starting at 5, and then going in this arrangement. And so that is inductive reasoning. If you wanted to look at it from a deductive reasoning standpoint, you would say that, let's say, y is equal to x plus 5. That's a rule. And so if this is the rule, this is the general concept, then, or you would probably use something like x sub n plus 1 is equal to x sub n plus 5. And then you'd have n where n is equal to 1, 2, 3, dot, 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 to whatever number n, actually not n, just to some number, we'll call it I, and x sub 1 is 5. X sub 0 is 5. So x sub 1 would be x sub 0 plus 5. So this is the rule, and therefore from this you can predict that it would be 30. You would know for a fact that it would be 30. This is we're assuming is 30. Okay, and let's do one more. Let's do 13. Well, no, that's not it. Let's actually let's stop that, and we'll start a new video.